I've worked in a number of schools where a lot of practical work that should be done, I don't think is being done. And I think it's because people lack the experience and the confidence. And what departments need to do is to work together to give newly qualified teachers and younger teachers the opportunity to carry these out and carry them out in a safe manner in which they feel confident.
Wariness over health and safety often deters new and non-specialist science teachers from attempting the kind of exciting chemistry experiments that are guaranteed to capture students' imaginations. At St James's High School in Barnet, Head of Science Lynn Kyle has been showing her staff that creativity and spectacle can be married with safe practice in the lab.
The number of students who are opting to take A-level chemistry, physics and biology is going down, and that's a national trend. It's more important than ever that we get people interested in science from a very early age and carry that through, pushing them into A-level and hopefully going back into teaching again.
We're going to see that the copper oxide is going to be reduced.
Wendy Butler studied biology at university, but when she became a teacher, she found herself having to incorporate chemistry experiments into lessons. Today, she is giving demonstrations of redox reactions to a Year 11 group.
So, what we're going to do today is we're going to put the theory into practice, and we're going to make Jelly Baby scream. And here's my Jelly Baby. Aww. Would you like it to go head first or feet first? Head first. Head first, we're all in agreement.
Wendy begins the lesson with an old favourite, the screaming Jelly Baby, in which sugar is oxidised by molten potassium chlorate.
I've picked up quite a lot of tips on how to actually practically manage the class and manage the experiment. So, for example, putting in anecdotes, giving little tips, talking through some of the experiments while they're happening. So we're going to oxidise the sugar in the Jelly Baby. Well, what process goes on in the body that does the same thing? Andre?
Respiration.
Well done, Andre. Respiration. Okay, I'm going to heat the potassium chlorate until it melts. And while it's heating, I'll tell you a little bit about Jelly Babies. They used to be called Peace Babies, and they were manufactured 75 years ago after the First World War. But obviously, as rationing came in, they didn't have enough sugar. So they had a bit of a facelift after the Second World War, and were called Jelly Babies. Now, it's just about reaching its melting point. I'm going to turn the gas off. I'm going to get my Jelly Baby.
Experience has taught Wendy that no matter how prepared you are, the unexpected can always happen.
But that's never happened before.
Fortunately, the precaution of conducting this experiment in a fume cupboard has meant that the Jelly Baby is the only victim, and Wendy continues undaunted.
It spat the Jelly Baby out.
What was supposed to happen?
Well, the Jelly Baby reacts with the potassium chlorate as it oxidises the sugar in it. Lots of gases are released, and as the gases are released, that's where you get the noise from. And you'll see, what characteristic flame colour would potassium have?
Lilac.
Lilac, well done. But we'll come back to it later, and hopefully Baby will be screaming by the end of the lesson.
There's always the risk that something will happen that you're not expecting. I think you've got to expect that with any experiment. If you've practiced it with an experienced teacher, if you're willing to adjust your practice as you go along, you can make that hazard minimised.
Although Wendy's experiment didn't go according to plan, she conducted it safely and confidently. Attending Lynn's twilight sessions for non-chemists and NQTs has helped her develop the skills to do so. Many of the experiments Lynn demonstrates have been selected because they will offer an exceptionally visual focus for students. She knows that most inexperienced teachers would shy away from them because of potential risks.
Many of the experiments that I'm going to be looking at have very definite hazards to them, but they are hazards that you can minimise, virtually eliminate. And it does come back for a final kick, which is something you have to be aware of. There it goes. As well as being part of the actual bit of science that you're teaching, for example, if you were teaching respiration, or if you were teaching redox reactions. It's a nice little filler at keeping up their interest as well. I mean, I know the children love it. Okay, this one's called Fireballs. Another one we can get in whenever we're doing combustion reactions. This makes that bit more exciting.
The twilight session provides Wendy with the opportunity to practice another experiment before presenting it to students.
So that we have a bubble of methane.
If I did this again, I think I'd have it other side so that I'd have my left hand on the gas tap. I think I feel more comfortable with it that way.
Okay. Would somebody jot that down in the risk assessment? Thank you. It's very important when you're doing an experiment that you're never ever doing it for the first time in front of a child. You want to have gone through the whole thing yourself, looking at all those potential risks, talked it through with someone else who has done it a number of times, who can tell you the risks that you might not have noticed, that have gone wrong for them, so that you're that much more prepared. If we make sure we get a bubble mixture that we're very happy with before we actually perform this in front of the children.
Instead of carbon dioxide going into the bubbles, we're going to put methane into the bubbles.
Having rehearsed the fireball experiment under Lynn's guidance, Wendy decides to include it in her lesson.
The methane fireballs was probably the most difficult one to do if you haven't quite perfected the correct bubble mixture. And it's very difficult to get the bubbles off if the bubble mixture isn't correct because they keep bursting. So you have to be very patient to fill the bubbles with enough methane but not over flood the classroom with methane gas. Mrs. Key is an expert at making bubbles, so I'm going to take the light.
As well as subject specialists like Lynn, technicians at the school also offer advice on risk assessments and health and safety. Wendy has called on senior technician Janet Keir to lend a hand.
Otherwise, as it goes. It's great. Again. That's it. It's going away. Well done, Miss.
A number of our demonstrations come from the Royal Society of Chemistry that have produced over 100 demonstrations of really exciting things that are beautifully prepared, all the risk assessments there and worksheets for the children as well. So that's really helped us in trying to do what we're trying to do. Pre-apps are fantastic. I mean, they produce hazard cards, you know exactly what the hazard with that particular chemical is. They give examples of good risk assessments with that particular practical. They tell you what you can do, what you shouldn't do. They offer an advice line as well, where you just need to pick up the phone and say, look, I want to do this, is this wise? And you will get an immediate answer. They're superb. Now please remember that you have got a flammable liquid here. You do have a naked flame, so you have to be very careful in its position.
Lynn shares another experiment with her staff. Having seen that a banknote-sized piece of paper soaked in water will not burn, and that paper soaked in ethanol will burn, pupils must predict what will happen to paper dipped in a mixture of water and ethanol. But to increase the suspense, the teacher will claim to run out of paper and needs to borrow a real banknote. In the lesson, the success of this experiment will depend on Wendy's showmanship.
Have you got any money on them? You've got a £10 note. Can I borrow it? Mm-hmm. Thank you. We're going to put it into the ethanol and water mixture. 25 centimetres of water, 25 centimetres of ethanol. What do you think is going to happen to the £10 note?
It turned into a £20 note?
Thank you, Lawrence. I would love that to happen, but we're going to find out. See if your prediction's correct. There we go. There's my £10 note. Shake off the excess, and we'll see if your prediction is correct. Has it burnt? The ethanol burns away. but the water keeps the temperature of the paper below its ignition point, so it doesn't catch alight. So therefore, Annette, you can have your £10 note back. So this is a perfect example of a redox reaction. It's going to take place, it's going to give out a huge amount of heat.
Redox reactions, for example, are not terribly exciting. You're looking at one thing reacting with another thing, and you don't get any idea of the, the amount of energy that's involved. Take, for example, the Thermit reaction. So violent that you can have molten iron at 3,000 degrees. On paper, that doesn't look very exciting, but when you actually see that experiment, wow, it really comes home to you what that reaction is all about and just how much energy is generated by it.
I think out of all of the experiments, the most successful one is the Thermit reaction, because we found a perfect recipe, if you like. The technicians have managed to perfect the best way of setting the equipment up for us, and it lights exceptionally quickly and has a great effect. The Thermit powder is bought in, so it's ready prepared. So it's just a matter of weighing out the correct measurements that we're going to use. Let's try it feet first this time. It certainly wouldn't, the lesson itself wouldn't have really had such an impact if it hadn't have been for those demonstrations. And the poor little jelly baby is howling. They wouldn't have been able to do those bench top, and it's good fun to round off topics. Marvellous. So yes, I was quite pleased with the experiments. Obviously there are hitches along the way which you have to cope with, but that's part and parcel of every lesson. When I started teaching, would have been quite a difficult time to think about just suddenly going into that. We're all specialised in certain fields, and with your degree and your PGC, some of the reactions you'll have tried out, but not all of them. And of course, in your first couple of years of teaching, you're very much aware of the knowledge side of teaching, the theory, the management, behaviour management, etc. So those things are sort of the extras, which can cause quite an extra bit of stress. But obviously with Twilight sessions, that's the prime opportunity to actually try them out.
Enthusiastic science teachers are what we need to make children come enthusiastically to science lessons. That's what we try to do, to put the life back into the chemistry again.
For comprehensive safety guidelines, including risk assessment forms and advice, science teachers can contact CLEAPS.